At this tutorial, we will focus on evolving our project by working on the menu Lua file. The menu system is a crucial component for any game, and we'll dive deep into its creation and functionality. Additionally, adjustments will be made to the main Lua file from the previous tutorial to align it with our current focus. For your convenience, all the necessary links and resources are available in the comments section. We begin by creating a table, which serves as a container to organize our menu functionality. In this case, the table is called menu. This table will hold all the logic and elements related to our menu system. Inside our menu system, we create a list of buttons, stored in another table called buttons. Each button is defined as an entry in this table with 3 components. The label displayed on the button. A function specifying what happens when the button is clicked. And a Boolean value, set to false initially, used to track if the button is being interacted with. We are not connecting the menu to any other game module or system. Instead, we use simple print statements. This allows us to focus on learning how to draw buttons on the screen, add background images and sounds, and handle clicking actions. This approach helps us stay focused on the core concepts of creating buttons, while avoiding distractions from game state management or module integration. Once the basic menu is working, we can expand to more advanced functionality. In this section of the code, we are defining several variables for button dimensions and other UI elements that will be used to create and style the buttons in the menu. These variables help us control the look and feel of the buttons, their spacing, and their shadow effect. Button width variable will store the width of the buttons. It will be calculated later based on the button height. Button height will store the height of the buttons. The height is set relative to the screen size to ensure that the buttons are appropriately sized on different devices. Button padding controls the space between the buttons. The padding ensures that buttons are not placed too close to each other, providing a better user experience. Button corner radius sets the rounded corners for the buttons. A value of 15 gives the buttons a smooth, rounded appearance. Shadow offset controls how far the shadow will be offset from the button. A value of 8 creates a noticeable 3D effect by placing the shadow a bit lower and to the right of the button. In this section, we are defining variables for the background image, button sound, menu sound, and the game state. These variables will help us manage the visuals and audio of the menu, as well as track the game's progress. Background image will store the image used as the background for the menu. It will be loaded later, and we can use this variable to display the background on the screen. Button sound will store the sound effect played when a button is clicked. It will be used to provide audio feedback to the player when they interact with a button. Menu sound will store the background music that will play while the menu is active. It will loop continuously, providing ambient sound to enhance the user experience. Game state tracks the current state of the game. Initially, it is set to loading, which means the game is in a loading phase before the menu is shown. We can later change this to menu once the menu has finished loading. The menu load function is responsible for initializing the assets and settings needed for the menu. It is called when the game is ready to show the menu, and it handles tasks like loading images, sounds, and setting the size of UI elements. Screen width is assigned to the value returned by the LÖVE2D getWidth function. This line retrieves the width of the screen. This value is stored in the screen width variable. It is useful for positioning elements and ensuring that the menu elements are aligned and scaled properly on the screen. Screen height is assigned to the value returned by the LÖVE2D getHeight function. Similarly, this line retrieves the height of the screen, storing the value in the screen height variable. The screen's height will be used to position elements vertically, ensuring they are placed in the correct locations relative to the screen size. These two variables, screen width and screen height, are essential for dynamically adjusting the layout of the menu and ensuring that it works across different screen sizes. They allow us to scale and center elements like buttons and backgrounds according to the screen's dimensions. Button height is assigned to the value returned by mathmin function, multiplied by 0.095. This line calculates the height of the button based on the screen size. It uses mathmin to choose the smaller of the two screen dimensions, either width or height. The smaller dimension is then multiplied by 0.095 to set the button height to 9.5% of that dimension. Button width is assigned to the value of button height multiplied by 3.5. This line calculates the width of the button based on the previously calculated height. The width is set to 3.5 times the height, ensuring the button has a proportional appearance on the screen. Button padding is assigned to the value of button height multiplied by 0.9. This line calculates the padding between buttons. The padding is set to 90% of the button height, providing enough space between the buttons for a clean layout. These calculations ensure that the button dimensions and spacing adjust dynamically based on the screen size, making the menu responsive and visually balanced. Background image is assigned to the value returned by LÖVE2D's new image. This line loads the background image for the menu from the specified file path. The new image function creates an image object using the file, and the resulting object is stored in the background image variable. The image will be used later in the code to display the background on the screen. This allows us to display a custom image as the background for the menu when it is drawn. Button sound is assigned to the value returned by LÖVE2D new source. This line loads the sound effect for the button from the specified file path. The new source function creates an audio object using the sound file, and the resulting object is stored in the button sound variable. The static parameter indicates that the sound will be fully loaded into memory. Button sound set volume assigns the volume of the button sound to 1. This sets the sound's volume to the maximum value. This ensures that the button sound will play at full volume when triggered. This allows us to play the sound when a button is clicked, providing audio feedback to the player. Menu sound is assigned to the value returned by the LÖVE2D new source function. This line loads the background music for the menu from the specified file path. The new source function creates an audio object using the music file, and the resulting object is stored in the menu sound variable. The stream parameter indicates that the music will be streamed from the storage, such as the hard drive or SSD, rather than fully loaded into memory. This is useful for larger audio files because it prevents them from consuming too much memory. Instead of loading the entire audio file into memory all at once, the audio is read and played in chunks from the storage as needed. Menu sound set looping assigns the value true to the looping property of menu sound. This causes the background music to loop indefinitely while the menu is displayed. Menu sound set volume assigns the volume of menu sound to 1. This sets the background music to play at full volume. Menu sound play starts playing the background music. This ensures that the music begins as soon as the menu is loaded. Finally, game state is assigned to the value menu. This sets the game state to menu, indicating that the game is now in the menu phase. This block of code ensures that the background music plays continuously while the player is on the menu screen. LÖVE Clear sets the background color to dark gray. The clear function is used to clear the screen and fill it with the specified color. The values 0.1, 0.1, 0.1 represent the red, green, and blue RGB components of the color, creating a dark gray background. LÖVE draws the background image to fit the screen. Background image is the image we previously loaded using LÖVE new image. The draw function is used to display the image. It takes several parameters. 0, 0 specify the x and y coordinates of where the image will be drawn on the screen. 0 specifies the rotation angle of the image, no rotation in this case. LÖVE get width divided by background image get width calculates the scale factor for the image's width, so it stretches to fit the screen width. LÖVE get height divided by background image get height does the same for the image's height, ensuring it scales to fit the screen height. This line ensures that the background image is drawn and scaled to fill the entire screen. The length operator when applied to buttons returns the total number of buttons in the buttons table. This gives us the count of how many buttons are defined in the table. Button height represents the height of each individual button. When we subtract 1 from the length of the buttons table, we get the number of gaps between the buttons. This is because the number of gaps is always 1 less than the number of buttons. For example, if there are 5 buttons, there will be 4 gaps between them. Button padding is the space or padding between each button. Now, we multiply by the subtraction of 1 from the length of the buttons table, which gives us the number of gaps between the buttons. This result is then multiplied by button padding, which is the space between each button, to calculate the total padding between all the buttons. Finally, we multiply the number of buttons by button height to get the total height that will be occupied by the buttons themselves. By adding these two values together, we get total buttons height, which is the total height required for all the buttons and the spaces between them on the screen. We assign to start y the result of subtracting total buttons height from the height of the screen, which is retrieved using LÖVE2D getHeight. Then, we divide this difference by 2. This calculation helps us position the buttons vertically in the center of the screen. By subtracting the total height of all the buttons from the screen height and then dividing by 2, we get the vertical starting point where the first button should be placed. This ensures that the buttons are evenly spaced and centered on the screen. We assign to center x the result of dividing the width of the screen, which is retrieved using LÖVE2D getWidth function, by 2. This calculation gives us the horizontal center of the screen. By dividing the screen width by 2, we find the middle point of the screen, which helps in positioning elements like buttons to be centered horizontally on the screen. We start a for loop where I represents the index, meaning the position, of each button in the buttons table, and button represents the actual button at that position. The function iPairs is used to iterate through each element in the buttons table in order. For each button in the buttons table, we calculate the position of the button. In this case, we are calculating the horizontal position, which is stored in the variable x. The x position is determined by subtracting half of the button's width from center x, which represents the center of the screen. This ensures that each button is aligned horizontally with the center of the screen. We subtract 1 from I and then multiply the result by button height add button padding. By subtracting 1 from I, we adjust the index so that the first button starts at the start y position, the vertical center. This ensures the first button starts at the center of the screen without any offset. Then, multiplying I subtracted by 1 by button height add button padding gives the correct vertical position for each button. Button height determines how tall each button is, and button padding determines the space between the buttons. This calculation moves each button down on the screen, placing them one after the other, with the correct amount of space between them. LÖVE2D set color is used to set the color for the shadow. The values 0, 0, 0, 0.5 represent black color with 50% opacity, meaning the shadow will be semi-transparent. Next, we use LÖVE2D rectangle to draw a filled rectangle, which will serve as the shadow of the button. The fill argument tells LÖVE2D to fill the rectangle with color. X added to shadow offset, and Y added to shadow offset, position the shadow slightly offset from the button, moving it down and to the right, creating the appearance of a shadow. Button width and button height set the size of the shadow to match the size of the button. The button corner radius values round the corners of the shadow, making it match the button's rounded corners. This code draws a shadow slightly below and to the right of the button, giving it a 3D effect. We define a variable button color and assign it the color 1, 0.07, 0.58, which is a pink color in the RGB color model and represents the default color of the button. Then, we check if the button.clicked property is true. If it is, this means the button has been clicked, so we change button color to 0.8, 0.05, 0.47, a darker pink color, to indicate the button has been clicked. This code ensures that the button's color changes from pink to a darker pink when the button is clicked, allowing users to visually see the change. LÖVE2D set color is used to set the color for drawing the button. Button color is the color we defined earlier, either the default pink or the darker pink when clicked. Next, we use LÖVE2D rectangle to draw the button. The fill argument means the rectangle will be filled with the set color. The position of the button is determined by X and Y, which represent the top left corner of the button on the screen. Button width and button height define the size of the button. Button corner radius is used to round the corners of the button, creating a button with rounded edges. This code draws the button with the appropriate color and shape at the calculated position, including rounded corners. LÖVE2D set color is used to set the color for drawing the button's border. The values 0, 0, 0 represent black color, so the border will be drawn in black. Next, LÖVE2D rectangle is used to draw the border around the button. The line argument tells LÖVE2D to draw just the outline of the rectangle, not a filled one. The position of the border is determined by X and Y, which represent the top left corner of the button's rectangle. Button width and button height define the dimensions of the border, matching the size of the button. Button corner radius is used to round the corners of the border, ensuring the border matches the button's rounded shape. This code draws a black outline around the button with the same rounded corners as the button itself. Once again, we use LÖVE2D set color to set the color for the button's text shadow. The values 0, 0, 0 represent black, so the shadow text will be drawn in black. Next, we calculate the dimensions of the button's text. The function LÖVE2D getFont is used to retrieve the font currently being used in the game. The method getWidth is called on the font object, returned by the function. This method calculates the width of the text string button text when drawn using the current font. Then, we use the same function to return the current font object, along with the method getHeight, to calculate the height of the text. This code calculates the size of the text based on the font used and prepares it for drawing, ensuring that it fits correctly within the button. The text will be positioned using the width and height calculations. The outer for loop iterates over the horizontal offsets, represented by dx, starting from -1 and going up to 4. The inner for loop iterates over the vertical offsets, represented by dy, also starting from -1 and going up to 4. The if condition ensures that the shadow is not drawn directly at the center. This is achieved by checking that dx is not equal to 0, and dy is not equal to 0 at the same time. Without this condition, the shadow would overlap with the actual text, making it look darker in the center. Inside the nested loop, we use the function LÖVE2D to draw the text shadow. Button text is the actual text string that will be displayed on the button. X added to dx and y added to button height divided by 4 and added to dy position the shadow slightly offset from the main text, creating a shadow effect. Button width specifies the horizontal space available for the text, ensuring the shadow is confined within the button's width. The center alignment ensures the shadow text is centered horizontally within the button. By looping through small offsets in both directions, this code creates a subtle and soft shadow effect for the button text, enhancing its visual appeal. After drawing the shadow for the button text, we proceed to draw the actual button text itself. The function LÖVE2D is used to set the color for the text. The values 1, 1, 1 represent white in the RGB color model, so the text will be drawn in white. Next, we use the function LÖVE2D to draw the actual button text. Button text is the string that will appear on the button. X determines the horizontal position of the text, ensuring it is aligned with the button. Y, added to button height, divided by 4, vertically positions the text within the button, ensuring it is not drawn at the very top but slightly lower to appear visually centered. Button width specifies the horizontal space available for the text, ensuring it fits within the button's width. The center alignment ensures the text is horizontally centered within the button. This code ensures that the button text is drawn in white, centered both horizontally and vertically, and stands out clearly against the background and shadow. We define a function called LÖVE2Press to handle touch input when the screen is pressed. The parameter ID refers to the unique identifier for the touch event. The parameter x is the x-coordinate of the touch point on the screen. The parameter y is the y-coordinate of the touch point on the screen. The parameter pressure represents how much pressure is applied during the touch. Inside the function, we first check if the game state is set to loading. If the game is in the loading state, touch inputs are ignored because the game is not ready for interaction yet. The function immediately stops execution and returns without performing any further actions. This ensures that no unintended actions occur while the game is loading. We calculate the horizontal center of the screen. The value center x is assigned to the result of dividing the screen width by 2. This gives the x-coordinate for the middle of the screen, which is used to center the buttons horizontally. We calculate the total height of all the buttons and their padding. The length operator is used to find the total number of buttons in the buttons table. Multiplying this length by button height gives the total height of all the buttons combined. Subtracting 1 from the length of the buttons table gives the number of gaps between the buttons. Multiplying this result by button padding calculates the total spacing between the buttons. Adding these two values together gives the total height required for all the buttons and their gaps. This value is stored in total buttons height. We calculate the starting y-coordinate for the buttons. the value start y is assigned to the result of subtracting total button's height from the screen height and then dividing this result by 2. This ensures that the buttons are vertically centered on the screen. This code calculates the positions needed to properly center the buttons both horizontally and vertically on the screen. We start a for loop where I represents the position or index of each button in the buttons table and button represents the actual button at that position. Local bx is assigned to the result of center x minus button width divided by 2. This calculates the x position of the button, positioning it horizontally in the center of the screen. Local by is assigned to the result of start y plus I minus 1 multiplied by button height plus button padding. This calculates the y position of the button, ensuring the buttons are spaced out correctly vertically. Local bw is assigned to the value of button width, which represents the width of the button. Local bh is assigned to the value of button height, which represents the height of the button. We check if the touch point is inside the button. First, we check if x, which is the touch point's x-coordinate, is greater than or equal to bx, which is the button's x position, and less than or equal to bx plus bw, the button's width. This ensures the touch point is within the horizontal bounds of the button. Next, we check if y, which is the touch point's y-coordinate, is greater than or equal to by, the button's y position, and less than or equal to by plus bh, the button's height. This ensures the touch point is within the vertical bounds of the button. If both conditions are true, meaning the touch point is inside the button, the following happens. Button action is called to execute the action assigned to the button and button clicked is assigned to true, marking the button as clicked. This code handles detecting if a touch occurs inside a button and then triggers the associated action for that button. We create a new variable called clickSound and assign it to the value returned by the function LÖVE2D, passing the file path and the string static as arguments. This loads the sound file into memory for immediate playback. Next, we use the play method on clickSound to play the button clickSound. Finally, we use break to exit the loop, ensuring that once a button is clicked and its action is triggered, we stop checking the other buttons. This function is responsible for resetting the clicked state of the buttons after a touch release. We start by defining the function LÖVE2D, which takes the ID, X, Y, and pressure parameters, representing the touch details when the touch is released. Inside the function, we loop through each button in the buttons table, using the iPairs iterator. For each button, we set its clicked property to false. This resets the state of the button, indicating that it is no longer in a clicked state. This function is responsible for loading the menu if the game state is loading. We start by defining the function LÖVE2D, which is automatically called when the game is initialized. Inside the function, we first check if the game state is set to loading. If this is true, it means the game is in a loading state. Then, we use the LÖVE sleep function to simulate a loading delay by pausing the game for 2 seconds. After the delay, we call menu load to load the menu, indicating that the game is ready to show the menu after the loading process. This function is responsible for drawing the current game state, which can either be loading or menu. We start by defining the LÖVE2draw function, which is called repeatedly to render the screen. Inside the function, we first check if the game state is set to loading. If so, we execute the following actions. LÖVE_graphics_clear is used to clear the screen and fill it with a black color, RGB values of 0, 0, 0. LÖVE_graphics_print displays the text loading. The position of the text is calculated using the screen's width and height to ensure it appears exactly in the middle. If the game state is set to menu, then the menu draw function is called to render the menu on the screen. Note, since we are using separate scripts for the loading screen and the menu, you do not necessarily need the last 2 blocks, they are optional. If you want to handle both the loading screen and the menu within the same script, keep these blocks to manage the loading state and transition to the menu. If you are using separate scripts for the loading screen and the menu, you can omit these blocks and manage the game state elsewhere. Before we wrap up, it is important to ensure all files are correctly placed in the working folder and its subfolders. This includes menu Lua, main Lua, and any related assets or dependencies. Proper file organization is crucial for everything to work seamlessly. Once that is set, you are ready to build on this foundation.